Hi, my name is Steve Ward and I'm going to talk about the ISA S95 standard for structuring data. S95 provides a mechanism for aggregating data for display and analysis. A big challenge is that the data in many enterprises is unstructured. Different departments, different machines, different plants all use different terminology, which makes it very difficult to correlate the different data items across similar standards and similar uses. The solution is to use a data model. This can provide a standard context across locations and data sources. That allows for analysis in context, and those context is derived directly from the model. This enables a common user experience regardless of the medium. S95 defines a hierarchy that can be used in tag and variable names, along with attributes that can describe the data. So a typical hierarchy in a tag or variable name could be the enterprise, although that's optional because often if you're only comparing data from one enterprise, you don't need that. And then you can add site, area within that site, production line or process cell, the unit or machine or asset, and then the measurement or variable. Attributes can include variable type, whether it's discrete or analog or text, engineering units, type of device, range and alarm limits, vendor, and even wire number. Here's an example of a tag or variable name. We have Acme as the enterprise, main plant as the plant name, assembly as the plant area, rotary valves as the type of device, test station 2 as the actual location, and valve 1 test pressure as the actual variable or device to be measured. Attributes could include that it's an analog device, we're measuring pressure in bar, it's a pressure sensor, and we have the range here 0 to 5 bar. And there may be additional attributes to help add more context around that data. Here are the requirements for a user to implement S95. You need to define which aspects of the hierarchy you're going to implement, and then you need to standardize terms, probably involving multiple people across the organization so that you can all agree. You need to decide on site names, production or process areas, machine types, measurements and variables and attributes, and possibly also thinking about how the plant may change or expand in future so that you can continue to use the same hierarchy as new items and new devices and new machines are added. Once defined, you can publish the standardized hierarchy in terms for all new projects, and then you can implement technology to handle that hierarchy. So you'll need devices that can handle full variable name, or you may need gateways that convert the current tag name or variable name into an S95 compatible tag name or variable name. You can also implement tag name changes on existing and new machines, but that may take some time and it may not be possible depending on how the machine is and what programming or configuration tools you have. What you can also do is store data in a centralized database to allow analysis. Start small to avoid huge capital outlay, and then with early successes, that can drive the process with proven results. Now this is a big task and it probably needs business level buy-in with executive support, and it definitely needs stakeholder agreement unless you agree that only part of the plant or process or enterprise will be covered. However, it is vital as part of the digital transformation to be able to have all these common names, otherwise it makes it extremely difficult to do any sort of comparison and to extract information from the data. Let's talk about data transmission and storage optimization. Ideally, all data will be stored, but this may be far too much data both to transmit over the network and to actually store in terms of data storage costs. So you can reduce the amount of data by storing only key data items. For example, you may have a large machine with thousands of data points, but if you're mainly concerned with overall equipment effectiveness or OEE, you only need 150 data items per machine, or possibly less, depending on how complex the machine is and how many breakdown reasons or stoppage reasons there might be. For analog data, you can reduce the amount of data by deadbanding. only store changes above a certain amount and not store every change. You also need to think about storing exceptions or alarms or events, especially for discrete data that doesn't change very often. This can help you understand what's happening with the machine and again have more context around events and machine behavior and performance. You can also consolidate or summarize data into meaningful time units. So maybe rather than have all of the data for all of the time, you may summarize data on an hourly basis or a shift basis or every day or every week. And as time goes on, the resolution of the data you require is reduced. So this might be something you do on a regular basis to reduce the historical amount of data required. Typically, you'll want to store averages and totals, not every value, but maybe you also need to think about storing minimum and maximum and maybe some other statistical data. Temporary storage is required for the data during the time period when you're doing the shift or other time unit, but once that data is summarized, the temporary data can be deleted. However, this does need additional work to actually perform the consolidation or summary calculations because the system or somebody needs to perform the analysis and the minimum and maximum data capture. However, many databases can perform this automatically via a stored procedure, or you could do it programmatically, but that facility would need to be created in the first place. There are other possibilities, although some of these go against standard IT type mechanisms. One option is to denormalize the SQL data in a database for faster data access. Now, the purpose of normalization is to reduce the amount of data storage required, but that can increase the time it takes to perform reports. So denormalization results in additional data being stored, but it can allow for faster results for reports and analysis. Another thing to do is store results of calculations as well as raw data. And for some regulated industries, you may have to do the raw data anyway. But the idea there is by storing the results of calculations, you can potentially do away with the raw data. As I say, you can lose traceability, but storing the results of calculations gives you a benefit in that you can have, again, that faster recall of data. But you also may need to store the raw data as well. But if you store the raw data as well, again, you're using more space than if you only store one or the other. Now, I'm talking about SQL databases here using structured query language, but there are other database formats such as MongoDB, InfluxDB, TimescaleDB. These are optimized for time series data, and they can significantly reduce the amount of time that it takes to process data and retrieve results, and they can also reduce the amount of disk storage required, as well as having the pure performance to begin with to be able to cope with what could be large amounts of data. You can also think about using a scalable cloud-based database instead of on-prem. This allows you to reduce your startup costs by renting a smaller server and a smaller amount of disk space, but that server and that amount of disk space you need may grow over time. However, it gives you the benefit of implementing software as a service, or SAS or SaaS, and it also moves expenditure from CapEx to OpEx, which can make budgeting easier.